So here let's frame. Again, this is a problem for Newton's law or dynamics. Newton's law, and it means it's about forces. Force is a vector, so maybe we can use component methods, maybe, because here I can see angle. If there is angle, likely we need to use components. And there is a friction force, so we need to take in account the friction force. Okay. Since we have forces, likely we need to draw free body diagram. Okay, now let's come to the forces. This was a framing. Let's plan it. More details. How many forces? What kind of forces we have here? We have a weight, yes, downward. We have a contact force or reaction force. It's perpendicular and it's to the left. And we have a friction force. What about direction of this friction force? Actually, it's opposite to its motion, but we don't have here any motion. At rest, no velocity, no acceleration, so it will be a bit difficult, challenging, the direction of the friction force. And what else we have? The force that we push it. P, its direction is given, and it's not horizontal, it's not vertical. It means we need to find its x component and the vertical component, y component. Acceleration equal to 0 because it's at rest. I think that's all. Basically, we have 4 forces: mg, reaction force, friction force, and the P. Okay. Now let's come to the solution part. Free body diagram. Let's start with free body diagram. This is our object. mg downward, reaction force. Here, horizontal to the right, we have a x component of the p times cosine 50 degrees, and the vertical upward we have a p sine 50 degrees. We have a last force, which is friction force, and we couldn't find exactly the direction of this friction force. Actually, it should be opposite to its motion, but no motion. So what we can do? So here we have two choices, two variants, and in both cases it will be stationary. It will be at rest. So the first one, when friction force will be upward. In second case, it will be downward, but object will be still at rest. So from here we have two variants, two possible answers. Basically, it will be minimum P and the maximum P. In both cases, it will be stationary, but friction force will be in opposite directions. Of course, since we are trying to find minimum and the maximum value, some range for P, so this friction force we should take as maximum. So it reached its maximum value, coefficient of friction times normal force. In this case, we will find maximum and the minimum value. Any value between these two values, minimum P and maximum P, it will be still at rest. maybe friction force may not reach its maximum value, but it's okay, it will be still at rest, it means. So let's start with the first case, when friction force upward, and this will be my x and the y direction. So resultant force in x direction should be equal to 0, because it cannot enter the wall or it cannot go to the left side. So it means no acceleration, no motion in horizontal direction. So it means the resultant force in x direction should be equal to 0 because of acceleration. Actually, Rx equal to max actually, but this one is 0. So in x direction we have p times cosine 50 and opposite n equal to 0. From here reaction force equal to p times cosine 50. Okay. Now let's come to the vertical component. Ry, resultant force in vertical direction, also should be equal to mass times acceleration in vertical direction. But the acceleration equal to 0 because at rest. So resultant force in vertical direction also should be equal to 0. Now let's come to the forces in vertical direction. Upward we have a p sine 50. Also we have an upward friction force, which equal to coefficient friction force times reaction force, because we are taking the maximum value. So mu times reaction force equal to p cosine 50, this is the friction force, equal to not minus weight equal to 0. Minus weight because it's downward, opposite to the y. So from here further is just mass equal to mg. From here p equal to mg divided by sine 50 plus mu cosine 50. So let's take our calculator. Mass is 3, gravity approximately 10, sine 50 plus mu 0.25 times cosine 50. My calculator gives me 32.3, approximately 32.3 newtons. What does it mean? If you apply force greater than 32.3 newtons, less than 32.3 newtons, it will go downward. This is a minimum force to keep it at rest. If you apply smaller values than 3.2, it will go downward, because friction force upward and it reached maximum value, and when you apply less force it will go downward. So it means this is a minimum value. Now let's come to the second case, when friction force is downward. In this case there is no any change in vertical direction. Again, reaction force will be same, p times cosine 50. The only difference will be here in second equation. Upward we have a p sine 50, downward we have a mg. So resultant force in vertical direction equal to 0. Upward we have a p sine 50, downward we have a mg, downward we have a friction force, which is mu p cosine 50 equal to 0. From here p will be equal to mg divided by sine 50 minus mu cosine 50. So in terms of number it will be equal to 30 divided by sine 50 minus 0.28 times cosine 50. Answer is 49.5, approximately 49.5 newtons. So we have a minimum value for p and a maximum value for p. So when you apply force greater than 49.5, it will move upward. If we apply force less than 32.3, it will go downward. So any value between 49.5 and 32.3 this object will be, this block will be at rest. How we can check it? How we can check it? I think. Now let's check how we can check. According to our solution, any value between these two numbers, it should be at rest. So let's check. Let me choose, for example, 40 newtons. So 40 newton is in this range. So it should be still at rest. Okay, let me create new page. So let's check. Upward we had P times sine 50, which is 40 times sine 50, and this will be equal to 30.6 approximately. Downward we have a weight mg, which is 30 approximately. In this direction we have a P times cosine 50, which is 25.7 approximately. To the right, to the left we have reaction force, also should be equal to 25.7 newtons. And it should be at rest. It means friction force downward, and it should be equal to 0.6. Now let's check. I think we can check the maximum value for this friction force, and this 0.6 should be less than maximum value, maximum possible friction force. Only in that case this block, this object will be at rest. So okay, let's go to the friction force. Maximum value, coefficient of friction force times reaction force, so 0.25 times 25.7, and it's approximately 6 newtons. Maximum friction force equal to 6, and it appears when it moves, when we have a sliding. So we are assuming that it's not moving, so it means friction force didn't reach its maximum value, so it should be less than 6. Here we have a 0.6 friction force, which is much more smaller than possible maximum friction force, which is 6. So it's not moving, it means. I think this is how we can check.